Okay, thanks all for joining. In this session, we have Daniel Saunders from Luminex, who will be sharing his knowledge around overcoming challenges of integrating the mainframe to a hybrid cloud infrastructure. As per usual, feel free to leave any questions you have in the chat box as we go along, and Daniel will answer any of your questions towards the end of the presentation. Also, we really appreciate if you could leave session feedback as well using the link that I'm about to paste in the chat box. And after the presentation, we really appreciate if you could fill out the form. And with that said, over to you, Daniel.
Awesome. Thanks so much. And thanks everyone for joining. I know it's a little bit different year with a virtual conference, but I'm happy to be able to speak and hopefully you enjoy the session. So today I'm going to talk a little bit about how to defy gravities, that as the session title says. And unfortunately, this is not a new initiative to put a mainframe on Mars. We're not talking about that to find that kind of gravity. So sorry to disappoint there, but we're really talking about data gravity. And I actually had this presentation up last night, and I was looking through it, and my wife looked at it and asked, "Well, what do you mean you're defying gravity? I thought you were in IT." And so I kind of tried to explain what data gravity meant to her a little bit, and kind of went into some technical jargon about how it's difficult to move data. And so what tends to happen is that data is created, and then it's hard to move that data to where it needs to be computed. So you end up computing it in the same place, and kind of snowballs, and so more and more data gets created in the same place, even if it's not the best idea to do that. And as you can imagine, my wife did not like that technical explanation too much. So I could try to go like a different route, and really it came down to kind of the same story as how my trusted beer fridge became a milk fridge once we had our first baby. And because what was happening is that our baby would wake up in the middle of the night, she'd want milk. We'd have to walk all the way downstairs, get her a bottle, walk all the way upstairs, give her a bottle. And you do that a couple times at night at 3 o'clock in the morning. You really get really tired of having to go up and down those stairs, move back and forth. And so what we ended up doing was we took my old mini fridge, you put it in our nursery, and that became the milk fridge. And that way, when our baby needed milk, we could just go into her room. It was already there, so the data was already there, and the consumer, in that case our baby, was right next to it. So we took away that transport cost of having to walk up and down the stairs every single time that she needed it. And so that kind of made a little bit more sense to her, in that what we're really talking about is that you want to easily be able to consume the data when you need it. So when you need milk, you want it to be right next to you, or you want it to be easy to go and get it. So I'll go through that a little bit more as we get in the presentation. But I'll just point out a little bit about, even in that milk example, that might not have been the best solution to the problem, because essentially what we were doing was kind of batching or preloading milk, in the room. And that's, I think, what a lot of companies do with their data right now, is that they load it beforehand, maybe in a nightly batch, load their database dump into a data lake, so it's there, instead of doing it on demand when they really need it. And you do that because it takes a lot of resources to pull that data off of the mainframe. And so you have to do it at a time when you have resources available. So for us, when it was daytime, when it needs to lock me down the stairs, we'd preload it so that it was there when we needed it. But really a better solution would be able to, in real time, grab that milk without having to go through the cost of going up and down the stairs. So maybe I should have built an elevator or something in my house, but that was beyond the cost that we could afford at that time. So I'll go into the presentation or a little bit. So that title, how to defy gravity and the integrated multi-cloud IT. There's a lot of buzzwords in there, and the main focus will be on that define data gravity. How can we reduce that transport cost of getting data off in the mainframe? Will be our focus. But first, just wanted to talk a little bit about why does this matter? Why do we want to get data off the mainframe? In the past, the mainframe has been considered a little bit siloed. Mainframe data was created on the with the mainframe. It was analyzed there, and it was acted on there. But we're really seeing across the industry that silo is being broken, and it's becoming more and more important that companies can access their mainframe data, their mission critical workloads across their enterprise. They need to be able to have that data in Hadoop so they can do MapReduce on it, and they need to be able to get that data out to their auditors. They need to be able to get that data out to their actuaries or the inventory teams, depending on what industry that they're in. So what ends up happening is, a IT team will come in and say, okay, we have to make this move to the cloud. We're building this data lake. We have to get the data there. But by the way, you can't use any more mainframe CPU to get the data there because our mainframes are already constrained. And so teams will start to kind of work on their offloading process, and then they find out that it can cost money and CPU resources just to move the data to the data lake. And so sometimes those projects fail just for that reason, that the cost of moving that data, it took too long, it took too much mainframe resources. And so they weren't able to do more for less. So that's you see that on this screen. It's kind of a phrase I was brought up with, and that either a product needs to do more, it needs to provide more features, or that product needs to help you save money. So that was kind of the old way that you could sell a product because it did more, you could sell it because it did less. But really in today's world, we're being asked to do more for less. We really have to combine that. And I think you see that even in the kind of the new era of COVID, of the pandemic, maybe a little economic uncertainty. Certainly companies are looking to do for less, but also in the IT world, I think there's never been a call for the need for more and more IT resources and capabilities as everyone goes remote, online shopping goes up. We're being constantly asked to do more. So do more for less becomes really important in that. So to get to that multi-cloud IT, to get to the point where you can get your data out to Hadoop, it can be combined with your open systems data, you do have to overcome that transportation cost, and that could be a hard task. I was looking at watching a session at another conference earlier this year, and they were talking about kind of the new analytics on Z offering and data gravity, and how a lot of moves to data lakes fail. And that's something I believe, because looking at other companies that have tried to do that, if you don't go about moving that data the right way, I can certainly see how that cost and resources you needed to move that data to the cloud would really kind of overcome a project and it would fail. But I think what we're seeing, and I hope to show you in this presentation, is that gravity does not need to be the obstacle that it once was. There are ways now to move that data that does not cost even close to the amount of resources on the mainframe that it used to, using traditional FTP or other methods. And so you're able to bypass the CPU consumption on the mainframe, and you're able to increase the speed and security of that as well. And so the question really then becomes, well, if the transportation cost of moving data is gone, what more can I do with my data? What new data lakes can I open up? What more Hadoop, and really what more insights for my company can I provide? And that's really, I think, become important in the new normal. I couldn't really do a presentation in this current pandemic without mentioning that probably the biggest buzzword across the world, which is the new normal. And so what does the new normal look like for the IT industry at this time? I think as probably all of you, it was kind of interesting to, in early March for us when we started kind of hearing about the lockdowns and what was going to happen. I personally wasn't quite sure what would happen with IT. Would we see less resources? Would it grow? And I think what we saw was almost an exponential growth of the amount of IT resources that were needed. I mean, all of a sudden, I know here in the States that, states are calling for COBOL programmers to come out of retirement to come in to help with their mainframe programs. And companies that normally saw peaks around, Black Friday and Christmas, we're seeing those peaks in March and April because the move to online shopping was just that gross and that sudden of a change. And so what happened was, mainframe CPUs and really all resources became quickly constrained. If you're kind of used to your peak just being what once a year around maybe year-end processing or Black Friday, you can kind of handle that. But all of a sudden that peak was happening every single day throughout March, April, and May, and continues to do so. And so really for a lot of those companies, that hybrid cloud approach became more important than ever. And we saw companies that had maybe a 2-year plan to kind of move to their hybrid cloud, all of a sudden that became a 6-month plan because they needed that flexibility, that they needed that the ability to bring up resources, analyze the data now or rather than in 2 years. And so I think really the pandemic and COVID kind of brought on a really rapid change and acceleration to this hybrid cloud movement. So I've mentioned a little bit about what data gravity is, and really what I'm most concerned about is what causes it, and in my opinion, the biggest cause of data gravity, of data kind of staying in one place, is that it can be hard to move. And so, why is it hard to move on the mainframe? Is that typically projects that are going to move data, even if it's doing DB2 offloads or doing XML data or vSAM files, they typically look to TCP IP or FTP transfers to make that move. And to me, I think that's a mistake, and I'll go into it because TCP IP, especially on the mainframe, is a communications protocol. It's meant to bring clusters and sync with each other. Maybe do some TSO sessions, and maybe some small file transfers. But it's not meant to move data. And so what's really meant to move data on a mainframe is the FICON channel. If you think about all data that resides underneath the mainframe is being written and read from the FICON channel right now. If you're writing from your DASD, you're using FICON. If you're reading and writing from your virtual tape, you're using FICON. And so really all that mainframe storage that's shown to be so difficult to move with TCP IP, it's already actually off the mainframe in some sense. It's on a peripheral that's attached via a FICON channel. And so what if you could use that FICON channel to get that data efficiently off the mainframe? Again, you use a protocol that is specialized for data transfer to do data transfer, as opposed to using protocol that's specialized for communication. And so that's what you can do with the MDI platform, is you can use that FICON channel that's specialized in transferring data to get the data actually off the mainframe and into your cloud, your data lake, your Hadoop, or kind of even a Kafka cluster, or a number of places that are outside the mainframe. So this just kind of shows some of the basic architecture that really helps make that happen. And you're going, from your mainframe. That's where your core business processing happens. We fully believe that the mainframe is here to stay. That's where your mission critical workloads are executed, and we think it will stay that way. It's important, but we also know that these data lakes, cloud providers are also here to stay, and that they specialize in their certain workloads. And so you can see with the MDI in the middle, we are that bridge that helps you make that hybrid infrastructure happen. So data gets sent down the FICON channel to our MDI platform. we understand how to read and write data off that FICON channel. And then on the flip side, we also are a open system server that understands how to use REST protocols, how to use NFS and other high-speed data transfer mechanisms on the open system side. And so we're able to kind of do that transformation for the mainframe while keeping that CPU consumption on the mainframe much, much lower. I think, you know, we've shown stats that transferring a file off the mainframe using FICON is about 97% less CPU on the mainframe than it is using FTP. And I'll talk a little bit more about why that is in a second. So I just want to go into a few use cases of how some companies are using this platform. And really, you know, I kind of always say with MDI, it helps, you know, the world is your oyster. You know, once you get that data off the mainframe in an efficient way, you're really free to really send it wherever it kind of makes the most sense for your business to go. And so maybe your company's building up a huge Azure data lake. So you're able to send that mainframe data there. Maybe you're kind of using Google Cloud and BigQuery to do analytics. So you can send the data to Google Cloud Storage. Maybe it just needs to go to another on-site open systems platform, and it just and so you need it to go be sent via NFS or into an NFS file share. And then at the bottom, you know, maybe your company is moving to more of an event-driven architecture, and you need data to be fed into Kafka, and we support that as well. And there's really a lot more use cases than this, but this is just kind of a little bit of a short summary. But the point is that once that data is off the FICON, once you overcome that data gravity, because you're not having to use that TCP/IP channel anymore, that you're freed up that data to move to any one of these big cloud providers or off-host processing platforms. So like I mentioned, in March and April, we saw just a dramatic rise in requests for this kind of technology because, you know, companies were starting to be constrained by their mainframes, and then they needed to get that data processed off host. And so we were able to go into a couple of those companies and help them out. And we did some benchmarking on, you know, what their processes were, and we saw a 97% reduced MSU usage. I think that was for like around a 50 gigabit file that had to be transferred off. They measured their MSU usage because it was, when trying to do FTP and actually SFTP, the amount of CPU that they were using was actually going to kill the project. It was just, they were not saving enough CPU by transferring that data off host versus just processing that file on the mainframe, because the SFTP usage was basically taking at least half of that CPU back. It was 2 steps forward, 1 step back. And that's because all that encryption that SFTP has to go into, all that creation of packets and the use of the TCP IP socket takes mainframe resources in a way that writing basically a tape to a FICON channel does not. And so our benchmark was able to show a 97% reduced MSU usage. And we actually run it faster as well. And that's because we're using, you know, both technologies as they're supposed to be used. The mainframe is writing data to a FICON channel, like it's designed to write data to. And then our open systems box was then using HTTPS and REST protocols to send that data into the cloud. So using both technologies as they're supposed to be used, we were able to actually reduce the clock time versus just trying to send that data directly to the cloud from the mainframe. Now here's a little bit more of the kind of results of that, and I know it can be hard to see on the screen, and see we have some artifacts kind of from the showing. But this is just showing a couple different ways to send data off the mainframe that we've seen customers try versus FTP, FTP from Unix System Services, and SFTP. And then versus our kind of using MDI, using the FICON channel, we're writing virtual tape using IBGener and IceGener. And you can see that the elapsed times of these, you can see similar to FTP, but dramatically reduced for SFTP. And then both for the FTP and SFTP, you can see a pretty significant reduction of MSU even from FTP, but a huge reduction from 75,000, that says, to under 1,000 using the IceGener of service units used. And the question always comes up, well, why is that reduction so big? And it's because SFTP is expensive because it has to do encryption on the fly in a way that the FICON channel does not. But I think most customers are moving to completely shutting down their FTP ports. I'm sure if you watch some of the security sessions around here, they'll tell you that port 21 is a very dangerous port to have open on the mainframe, because unsecure FTP is very dangerous and easy hackable way to steal data off the mainframe. So most customers do not allow FTP off the mainframe anymore. So they have to do SFTP, and that's a huge driver of that MSU usage when trying to get that data off the mainframe. So by using MDI, by using the FICON channel, we're really able to change the game and of what you can do with mainframe data and where you can send it. Because now you can securely, fast, and easily send data off the mainframe. So you can actually move large amounts of data, which I'm talking terabytes and more a day off the mainframe, which can easily feed it a data lake. You can do analytics off host. You can do actuarial work off host, and a number of other things. And it's easily integrated, again, with the big players in the open system or the cloud world. So whether it's Kafka, Azure, AWS, things like Snowflake that are coming up. We are able to feed that data, get that mainframe data there without having to see that dramatic spike in MSU usage that just comes from transferring data. All right, so we went over a few of these architectures already, but I think it's worth highlighting a few of them again. So when using MDI, we touched a little bit on the security, but by using the FICON channel, direct connect, and then using HTTPS off the back end, you're creating a very secure method for transferring data. So it's much more secure than having that port 21 FTP port open on the mainframe. Certainly, orders of magnitude more secure than doing a plain text FTP transfer. And it's, of course, something that we've had many customers, have their security team audit and review, and they were very happy with. It's also good, again, it's a way to be faster and efficient. And when we talk about, when I talk about defined data gravity of overcoming the obstacles of the difficulty of moving data, it's really about speed and efficiency. How fast can I get the data there, and how many CPUs, how much MSU is it going to take me to do it? And I think that's where MDI really shines, in that we're able to get the data there still extremely fast, because we're using that FICON channel which is optimized for data transfer. And at the same time, you're going to dramatically reduce your CPU usage. So you're doing more for less there. And so what that means for you is that you have better business analytics and insights available for you. That mainframe data is no longer siloed. You have access to data on demand, and you're able to really bring that what I consider the mission critical data. The data, your mainframes are running applications that are core to your business, and so having that data is kind of siloed and only available on the mainframe is a disadvantage when you're looking at doing business-wide analytics. But by bringing it all together on a cloud, you're able to provide that insight to your data scientists and others, so they can have information across the whole enterprise. So again, the whole idea of hybrid cloud with the mainframe, at least as I see it, is that the mainframe is optimized for mission critical workloads. You want your inventory systems, your payroll, what makes your business function really running on that mainframe. It's a reliable, secure operating system and environment. But there are other things that a data lake can be better for. And so, in an ideal world that you didn't have to pay data transfer costs to move data around, you'd run workloads that made sense on the mainframe. So you'd run your mission critical apps on the mainframe, and you'd run your analytics and other tasks on the cloud, where maybe it's a little bit cheaper, it's a little bit more flexible, and it's optimized for doing huge map reduces and other data science operations. But again, the mainframe still needs to be there. The mainframe, I think, will still be an important part of IT for many years to come, is because it can support those mission critical applications. And so what we really want to do with MDI is really support the mainframe, support that it's growing to do its mission critical applications, but also allow it to no longer be siloed, for it to move into kind of the new cloud world that is developing and really, I think, here to stay as well. So the mainframe is now kind of cooperating in the new age instead of being kind of left out on its own silo. And so that's really kind of the whole slide. And slide deck, and I'll open it up to questions here in a few seconds. But if you can really kind of get any point out of the presentation, it's that moving data does not have to be expensive. Data gravity does not have to define how you do your workloads. It may make sense for you to do analytics on the mainframe, but I think in a lot of cases it does not. There are a lot. If you already have a big data lake, it really makes sense to get your mainframe data into that data lake that's already created. And so there are many other ways. There are many other reasons why it makes sense to move data back and forth. And I'm sure you kind of get those pressures maybe from your peers, and being asked, how can I get this data fed to my data lake? But if you've looked at it and you've tried to do transfers yourself, you know that moving the mainframe data can be a very cumbersome task. And so by using the mainframe channels that are designed for data transfer, you can really overcome that transportation piece. And it really opens up your enterprise and your analytics to everything that the mainframe data has to offer. And so that's really the end of the presentation. But MDI is a great way to move data to support your hybrid cloud infrastructure. And again, the whole idea is that we believe the mainframe is here to stay, and we want it to thrive and into the next decade and beyond. And so we think this is an important part of that. I'll stop for questions now. I just wanted to make sure to put some new updates also with Luminex, is that we do have a new operations hub that's in Manchester. So this is GC UK. So that's exciting news for EMA. And so we have the number here and the website here for those of you that are in that area. But providing local time zone sales and support to EMA now, which is exciting news for us. And then there's a session feedback slide, but if there are any questions now, I know I try to keep my slides short so we don't run over and we have some time for questions. So if you have any questions, please let me know and I can try and answer them now.
Thanks so much, Daniel, for the really detailed and insightful presentation. If anyone does have questions, feel free to just use the chat box or signal to me through the chat box, and I can unmute you if you prefer to talk in person instead. So I can give you a few moments.
Yeah, and if you have questions or really if you kind of have any experience moving with the hybrid cloud, I'm going to be interested to kind of talk through that as well.
Okay, I don't think we've got any questions coming through at the moment, Daniel, but I'm sure that people can follow up with you after the session as well, if that's possible.
Yep, absolutely.
Sure. Perfect. Well, Daniel, again, thank you so much for your time today. We really appreciate that. Attendees, thank you so much for joining. By the way, if you are enjoying the free conference this year, we would really appreciate if you could help us achieve our charity target of £2,000 as well. We've reached £450 so far. So I'm going to paste in the link to the Virgin Money Giving page, and we would really appreciate any donations that will be going to the NHS charities together. It would certainly mean a lot. And again, really appreciate any session feedback as well.